Hello students, welcome to your channel Parivartan Physics. So in this video, we are going to learn a practical called as sonometer, right? Sonometer, there are two aims in this practical. So I will be performing these two practicals in two parts. So in the first part, we'll be studying the relation between frequency and the resonating length, keeping the weight constant. And in the second aim, or in the second video, we'll be changing the weight and we'll be keeping the frequency constant. So frequency constant itಕೊಂಡು ನಾವು weight change ಮಾಡ್ತಿರ್ತೀವಿ. It means we are going to study the relation between that tension and the resonating length. In the second part of this practical, right? So in the first part of the practical, we are going to know the relation between frequency as well as resonating length, keeping the weight constant. This is what we are going to perform in this video, right? So the second half will be performed in one more video which will be uploaded right after this video. See, dear students, if you are new to this channel, please don't forget to subscribe the channel and please share the video, share the channel with your friends. Please mouth spread and please speak about the channel in front of your friends, right? And please go through the channel once. Please visit all the playlists in the channel. You will find number of useful videos for you which will surely help in your preparation of NEET KCET board exam as well as practical examinations. This channel is specially made for Karnataka students. So ಎಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್ ನಾನು ಕೇಳ್ಕೊಳ್ಳೋದು ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಪ್ಲೀಸ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಅಂಡ್ ಪ್ಲೀಸ್ ಶೇರ್ ದ ಚಾನಲ್ ಆಸ್ ವೆಲ್ as ವಿಡಿಯೋ with your friends as well as with your juniors, right? Okay, so that's all about my request. So we'll start with the practical right now. We'll see everything in detail about the practical in this video. Okay, let us begin. So this is the instrument we are going to use called as sonometer, right? Okay, so we got to know this is the sonometer, which the instrument we are going to use. Sonometer has two, see, 1 meter long scale. It has 1 meter long scale. You can observe it here. So ಇಲ್ಲಿ ನಮಗೆ 0 centimeter ಇದೆ, correct? So from 0 to this is 100 centimeter, right? So 100 centimeter scale ಇದೆ, 100 centimeter ಅಂದ್ರೆ 1 meter scale ಇದೆ. And there will be two sharp knife-edged bridges here. So ಇದೊಂದು ನಮಗೆ knife-edged bridge ಇದೆ, and this is one more knife-edged bridge. So here we are having the steel wire. So steel wire the sonometer ಇದೆ ನಮಗೆ, right? So this is the steel wire. See, and we are going to use a paper rider which will be kept on the wire like this. This is called paper rider. See, one end of the sonometer wire will be fixed. It will be tied to a rigid support, and another end of the sonometer will be hanged with the weight. So here we are having the weight. So idu namagu weight adare, right? So this is the hanger. See, each slotted weight will be of 500 grams here. See, you can see it is written on that 500 grams, right? So the first of the stand ಏನದಲ್ಲ, I mean ಇದು hook plus ಇದು last ಏನು ನಮಗೆ ಕಾಣಿಸಿದೆ, this one, right? So ಈ hook plus ಇದು last one ಏನಂದ್ರೆ ಇದು ಹಿಡ್ಕೊಂಡು ನಮಗೆ ಇದು 500 grams ಅದು ಇರ್ತದೆ. It will be of 500 grams. So this is 500 plus 500, 1 kg ಐತೆ, ಇದು 1.5 kg, 2 kg, 2.5 kg. So the total weight I have taken here is 2.5 kg, right? So 500 grams plus 500 grams, so 1 kg, 1.5 kg, 2 kg, 2.5 kg. So I kept 2.5 kg weight here. Clear? So you got to know the mass we have taken here is 2.5 kg. Okay, other than this, what we are going to use is, we are going to use the resonant, the tuning forks here, right? We are going to use the tuning forks of different frequencies. So you can observe the frequencies there. So ಇಲ್ಲಿ ನಮಗೆ first 256 hertz ಇದೆ, 288 hertz, 341 hertz, 426, 512 hertz. So these are the different tuning forks we are going to use, right? So that's all about the apparatus which we are going to use. Next, we'll go for the procedure of this experiment. Okay, so this is the chart we are going to follow for the experiment called as sonometer. See, as I have told you in all the practicals, I have told you there is no need of writing aim, apparatus and procedure in your practical examination. Other than that, everything you have to write, right? Okay, so what is the aim of this practical? There are two aims of this practical. In this video, we are going to accomplish this aim. Under first aim ಏನದ ಇದನ್ನ ಮಾತ್ರ ನಾವು ಈ ವಿಡಿಯೋ ಒಳಗೆ ಮಾಡ್ತೀವಿ. For this I am going to do one more video. So ನಿಮಗೆ ಮತ್ತೊಂದು ವಿಡಿಯೋ ಇತರ ಈ ಪ್ರಾಕ್ಟಿಕಲ್ ಮೇಲೆ ಬರ್ತದೆ. So the first aim is to study the relation between frequency and length. So ನಾವು ರಿಲೇಷನ್ ಯಾವ ತರ ನಡುವೆ ಫೈಂಡ್ ಮಾಡೋದೇವಪ್ಪ ಅಂತಂದ್ರೆ in between frequency and length. Frequency and length. So we are going to study the relation between frequency and length of a given wire under constant tension. Under constant tension. ಸಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆನ್ಷನ್ ಅಂತಂದ್ರೆ ನಾವ್ ಇಲ್ಲಿ ಏನು ವೇಟ್ ಹಾಕಿರ್ತೀವಲ್ಲ ಆ ವೇಟ್ ನಮಗೆ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಕೋಬೇಕು. ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆನ್ಷನ್ ಅಂತಂದ್ರೆ ವೇಟ್ ಶುಡ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್, ರೈಟ್? ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಎಫ್ ಅಂಡ್ ಎಲ್ ಕೀಪಿಂಗ್ ದ ವೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಅಥವಾ ವೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ ಟೆನ್ಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ ಅಂತ ಯೂಸಿಂಗ್ ಸೋನೋಮೀಟರ್. So this is the first aim. Second aim is to study the relation between length of a given wire and tension for the constant frequency. Length ಮತ್ತು tension ನಡುವಿನ relation ನಾವು calculate ಮಾಡಬೇಕು. We are going to find keeping the frequency constant. So this time frequency is going to remain constant. So second aim ಒಳಗೆ ನಮಗೆ frequency constant, first aim ಒಳಗೆ weight constant. So in this practical we are going to perform this one, first one in this video. Right? Okay. On this aim, we'll do one more video. So, mattond video ಒಳಗೆ ನಿಮಗೆ ಇದು ಸಿಗ್ತದೆ. Okay. Next. So, we are going to the first one now. First aim now follow ಮಾಡಿದ್ದೇವೆ. So, what is the principle? Principle of resonance. The wire between the movable bridges vibrate with maximum amplitude when the frequency of air column is equal to the frequency of tuning fork. ಸೊ ಇಲ್ಲೇ ನಮಗೆ ಮೇನ್ಲಿ ರೆಸೋನೆನ್ಸ್ ಗೊತ್ತಿರಬೇಕು. ವಿ ಶುಡ್ ಬಿ ನೋಯಿಂಗ್ ರೆಸೋನೆನ್ಸ್. ಸಿ ರೆಸೋನೆನ್ಸ್ ಅಂದ್ರೆ ಏನ, ಫೋರ್ಸ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂಡ್ ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಮಸ್ಟ್ ಬಿಕಮ್ ಈಕ್ವಲ್, ದೆನ್ ದ ರೆಸೋನೆನ್ಸ್ ವಿಲ್ ಆಕರ್. ಸೊ ಇಲ್ಲೇ ಫೋರ್ಸ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಮತ್ತು ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತಂದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಮಸ್ಟ್ ಬಿಕಮ್ ಈಕ್ವಲ್ ಟು ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ವೈರ್, ವೈಬ್ರೇಟಿಂಗ್ wire. So when the frequency of the tuning fork and frequency of the vibration of the wire becomes equal, at that time resonance occurs. That is the principle. Okay, formula is force frequency into the length. Length means resonating length, right, in the fundamental mode, right? Okay, so that's all about the principle as well as formula. See, the diagram is like this. This is the sonometer box. Here we are having two knife-edged bridges called as A and B, and here we have the paper rider. This is the paper rider. Resonating length is the length between these two sharp knife-edged bridges. Even ನಮಗೆ ಮೂವೇಬಲ್ ಶಾರ್ಪ್ ನೈಫ್ ಎಡ್ಜೆಡ್ ಬ್ರಿಡ್ಜಸ್ ಇದಾವಲ್ಲ, ಇವ್ರ ನಡುವಿನ ಡಿಸ್ಟೆನ್ಸ್ ನಾವು ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಅ ಪುಲಿ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ವೈರ್, ಸ್ಟೀಲ್ ವೈರ್ ನಮಗೆ ಸೋನೋಮೀಟರ್ ಅದ, ಅಂಡ್ ಹಿಯರ್ ಇಸ್ ದ ವೇಟ್, ರೈಟ್? ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ನೋಟೆಡ್ ಡೌನ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್. Okay, and the graph is like this. See, we are going to plot the graph of frequency versus reciprocal of length. Frequency versus reciprocal of length, which will be a straight line passing from the origin. Origin in the pass of the straight line. Next note, tabular column. We'll go for the observation table now. So observation table ಒಳಗೆ ನಮಗೆ ಇಲ್ಲಿ frequency first column ಅದ, resonating length, frequency into length, 1 by length, right? Okay, so ಇಲ್ಲಿ ನೋಡ್ರಿ, we are going to perform the experiment in which we are going to study the relation between frequency and the length. Frequency ಮತ್ತು resonating length ನಡುವೆ ನಾವು relation find ಮಾಡೋದು. We are going to find the relation between frequency and length. We are going to keep the weight constant. Weight now fixed constant ಇಟ್ಕೊಳ್ಳೋದು. Correct? Okay. So as I have shown in the apparatus itself, the weight here we have kept it as 2.5 kg. Now we'll 2.5 kg weight fix ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. Right? Weight ನಾವು ಏನು ಚೇಂಜಸ್ ಮಾಡಂಗಿಲ್ಲ. What we are going to change? We are going to change the frequency. So ನೋಡ್ರಿ, resonating ಇಲ್ಲೇ ನಾವು ಡಿಫರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂತ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ಸ್ ಗಳನ್ನು ತಗೋತೀವಿ. So the first tuning fork we are going to use is of 256 hertz, right? So ಇಲ್ಲಿ ನಿಮಗೆ ಕಾಣಿಸ್ತದ್ರಿ 256 hertz. This is the frequency of the first tuning fork which we are going to use. So first one is of 256 hertz. Okay, after that next one we are going to use 288, right? So you can observe here it is 288 hertz. Okay, so second trial is for 288 hertz. So like this, the next one is 341 ಅದರ ನೆಕ್ಸ್ಟ್ ನಮಗದ 426 and 512 hertz, right? So these different tuning forks we are going to use. For these different tuning forks we will now practically calculate the values of resonating length. We'll find the resonating length and then we'll proceed with the procedure, right? Okay, now let us go to the apparatus. Okay, first let me tell you the procedure completely in few minutes, and then we'll go step by step of that practical, right? We'll have a close look of the instrument, how to take the readings, how to set the tuning fork in vibration, how to know whether the resonating length we have reached and all. ಅದನ್ನೆಲ್ಲ ನಾವು ಕ್ಲಿಯರ್ ಆಗಿ ಆಮೇಲೆ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ನೋಡೋಣ ಅಂತ. ಫಸ್ಟ್ ಈಗ ನಾನು ನಿಮಗೆ ಕಂಪ್ಲೀಟ್ ಪ್ರೊಸೀಜರ್ ಏನ್ ಮಾಡೋದು ಅದಲ್ಲ ಈ ಪ್ರಾಕ್ಟಿಕಲ್ ಒಳಗೆ, ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಇನ್ ದಿಸ್ ಪ್ರಾಕ್ಟಿಕಲ್, ದಟ್ ಐ ವಿಲ್ ಟೆಲ್ ಯು ಇನ್ the summary of that I will tell you in short, right? See, what we have to do is, here we are having two knife edged bridges and we know we are going to use 5 different tuning forks here. So the first tuning fork which I am going to use is of 256 hertz, right? I have already shown you this. The frequency will be written on that tuning fork. So first tuning fork I am going to use it is of 256 hertz. See, 256 hertz tuning fork ಅಂತ ತಗೊಂಡು ಈಗ ನಾನು ವೈಬ್ರೇಷನ್ ಒಳಗೆ ಸೆಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ I will keep the distance between the two knife edged bridges as 30 ಸೆಂಟಿಮೀಟರ್ ನಾ ಈಗ ಎರಡು ನೈಫ್ ಎಜ್ ಬ್ರಿಡ್ಜಸ್ ನಡು ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಇಟ್ಕೋತೀನಿ ಅಂದ್ರೆ 30 ಸೆಂಟಿಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ನ ಇಟ್ಕೋತೀನಿ. ಐ ವಿಲ್ ಕೀಪ್ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 30 ಸೆಂಟಿಮೀಟರ್, right? Okay, because my tuning fork is of 256 hertz. If your tuning fork is having the frequency greater than this, then the length you should keep less. Andre distance between the bridges you should keep it less, right? Andre ನೀವು frequency of tuning fork ಅನ್ನು ಜಾಸ್ತಿ ಮಾಡಿದಂಗೆ resonating length ನಮ್ ಕಮ್ಮಿ ಆಗೋತ ಹೋಗ್ತದ್ರಿ. That is what we are going to learn now. ಅದು ನಮಗೆ ಗೊತ್ತಾಗ್ತದ್ರಿ. But I am telling you in earlier that if you go on increasing the frequency of the tuning fork, the resonating length or the gap between the bridges goes on decreasing. ಸೊ ನೀವು ಇನ್ನು ಮುಂದೆ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನಾ ಈಗ 256 ಹಿಡ್ಕೊಂಡು 512 ತನಕ ನಾನು ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೆಚ್ಚು ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀನಿ. ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಅವ್ರ ನಡುವೆ ನಾ ಕಡಿಮೆ ಮಾಡ್ಕೊಂತ ಬರ್ತೀನಿ. ಓಕೆ, ಸೊ ನಾವು ಪ್ರೆಸೆಂಟ್ಲಿ ಐ ಹ್ಯಾವ್ ಕೆಪ್ಟ್ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ 30 ಸೆಂಟಿಮೀಟರ್ ಇನ್ ಬೋತ್ ಆಫ್ ದ ನೈಫ್ ಎಜ್ಡ್ ಬ್ರಿಡ್ಜಸ್. ವಾಟ್ ನೆಕ್ಸ್ಟ್? ಅದಾಗಿದ್ ಕೂಡಲೇ ನೀವ್ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಯು ಶುಡ್ ಟೇಕ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್. ಯು ಶುಡ್ ಹೋಲ್ಡ್ ದಿಸ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಕರೆಕ್ಟ್ಲಿ. ನೋಡ್ರಿ, ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಹೆಂಗ್ ಇಟ್ಕೋಬೇಕಂದ್ರೆ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಸ್ಟೆಮ್ ಆಫ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್. ಯು ಶುಡ್ ಹೋಲ್ಡ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ವೈಬ್ರೇಷನ್ ಒಳಗೆ ಸೆಟ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೂ ಕೂಡ ಅಲ್ಲಿ ಸೋನೋಮೀಟರ್ ಟಚ್ ಮಾಡಬೇಕಾದ್ರೂ ಕೂಡ ಈ ತರ ಹಿಡ್ಕೊಬೇಕು. ಯು ಶುಡ್ ನೆವರ್ ಹೋಲ್ಡ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಹಿಯರ್. ಇಲ್ಲೇ ನೀವು ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಹಿಡಿಬಾರ್ದು, ರೈಟ್? ಅಂಡ್ ಯು ಶುಡ್ ನಾಟ್ ಟಚ್ ದಿಸ್ ವೈಲ್ ವೈಬ್ರೇಟಿಂಗ್. Clear? So hold the stem and then set it into vibration. So you hold it vertically like this. You don't hit it like this. Ee tara hit ಮಾಡಬೇಡಿ. You don't hit it like this, right? You hit it like this. Then it will set into the vibration. Correct? So you hit it to the rubber pad. Rubber pad ಗೆ ನೀವು hit ಮಾಡ್ರಿ, ಆಮೇಲೆ ಇದು ವೈಬ್ರೇಟ್ ಆಗ್ತದ್ರಿ. ಆ ವೈಬ್ರೇಷನ್ ಇದ್ರೆ ನಿಮಗೆ ಸೌಂಡ್ ಕೂಡ ಗೊತ್ತಾಗ್ತದೆ. I will show you that. See. So I guess you are listening the sound and it will set into the vibration like this, right? Okay, well, so now what we'll do is we have to set this into the vibration. ಈಗ ನೀವು ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇದನ್ನ ರಬ್ಬರ್ ಪ್ಯಾಡ್ ಹಿಟ್ ಮಾಡ್ಕೊಂಡು ಈ ತರ ವೈಬ್ರೇಷನ್ ಒಳಗೆ ಸೆಟ್ ಮಾಡಿ you should hold that tuning fork on the sonometer like this. ಅಂದ್ರೆ ಈ ಇದು ಏನ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ದ ಸ್ಟೆಮ್ ಅದಲ್ಲ, ಈ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ದ ಸ್ಟೆಮ್ ನೀವೆಲ್ಲ ಪ್ರೆಸ್ ಮಾಡಬೇಕು. ಯು ಶುಡ್ ಪ್ರೆಸ್ ಅಂಡ್ ಹೋಲ್ಡ್ ಇಟ್ ಆನ್ ದ sonometer. ನೀವು ಎಲ್ಲಿ ಬೇಕಾದ್ರೆ ಹಿಡ್ಕೋಬಹುದು. ಈ ಫ್ಲಾಟ್ ಸರ್ಫೇಸ್ ಏನದ ಅಲ್ಲಿ ಹಿಡ್ಕೋಬಹುದು, ಇಲ್ಲ ಇಲ್ಲಿ ನಮಗೆ ಸ್ಕೇಲ್ ಅದ, ಆ ಸ್ಕೇಲ್ ಮೇಲೆ ಕೂಡ ನೀವು ಈ ತರ ಹಿಡ್ಕೋಬಹುದು. You can press that stem and hold it like this. So after setting it into the vibration, you press the stem of the tuning fork on the sonometer scale, right? Okay, aವಾಗ ಏನ್ ಮಾಡ್ಬೇಕು ನೋಡ್ರಿ. First I will set it into the vibration. I will hold it on the scale like this and check whether the paper is vibrating or no. ಆ paper rider ನೀವೇನಿಲ್ಲ ವೈರ್ ಮೇಲೆ ಹಾಕೊಂಡಿದ್ರಲ್ಲ, ಆ paper rider vibrate ಆಗತ್ತದೋ ಇಲ್ಲೋ ನೋಡ್ರಿ. If it is not vibrating, what you have to do? You should move any one of the bridge, either this one or this one, by 1 centimeter. 1 centimeter move madri. Increase the length by 1 centimeter. Okay, so I have kept at 30 centimeter now. 31 centimeter ಇಟ್ಕೋತೀನಿ. Again we should set in vibration and we have to check. ಅದು ಸ್ಲೈಟ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗೈತೆ ಅಂತ ಇಟ್ಕೋರಿ. ಮೊದಲು ಒಟ್ಟ ವೈಬ್ರೇಟ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ. ಯಾವಾಗ 30 ಸೆಂಟಿಮೀಟರ್ 31ಕ್ಕೆ ಸ್ವಲ್ಪ ವೈಬ್ರೇಟ್ ಆಗ್ಲಿಕ್ಕೆ ಶುರು ಆಯ್ತು ಅಂತ ಇಟ್ಕೋರಿ. Again increase the distance by 1 centimeter. 32 centimeter ಇಟ್ಕೋರಿ. Again set the vibration, hold it to the sonometer and check whether it is vibrating more or no. ಅದು ಜಾಸ್ತಿ ವೈಬ್ರೇಟ್ ಆಗಕತ್ತಿತ್ತು ಅಂದ್ರೆ ನೀವು ಲೆಂತ್ ಅನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. ವೈಬ್ರೇಷನ್ ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ಯು ಶುಡ್ ಡಿಕ್ರೀಸ್ ದ ಲೆಂತ್ ಅಗೇನ್. ಲೆಂತ್ ನೀವು ಮತ್ತೆ ಡಿಕ್ರೀಸ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಯಾವುದೋ ಒಂದು, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 32 ಸೆಂಟಿಮೀಟರ್ ಬಂದ ಕೂಡಲೇ ನನಗೆ ವೈಬ್ರೇಷನ್ ಹೆಚ್ಚಾಯ್ತು ಅಂತ ಇಟ್ಕೋರಿ. ಎಲ್ಲಿ ವೈಬ್ರೇಷನ್ ಜಾಸ್ತಿ ಕಾಣಿಸೋದಲ್ಲ ಅಲ್ಲಿಂದ ನೀವು 0.5 ಸೆಂಟಿಮೀಟರ್ ಮಾತ್ರ ಹೆಚ್ಚು ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. 0.5 ಸೆಂಟಿಮೀಟರ್ ಹೆಚ್ಚು ಮಾಡ್ರಿ, ಹಿಟ್ ಇಟ್ ಅಂಡ್ ಚೆಕ್ ವೆದರ್ ದ ವೈಬ್ರೇಷನ್ ಇಸ್ ಕರೆಕ್ಟ್ ನೌ. Like that you should go on increasing, and at a certain length, ಯಾವುದೋ ಒಂದು ಲೆಂತ್ ಬಂದ ಕೂಡಲೇ ಏನಾಗ್ತದ್ರಿ, ಪೇಪರ್ will vibrate, the wire will vibrate with maximum amplitude and the paper rider will fall down, and then you have to stop your procedure, right? And then you should note down the length or the distance between the two knife edged bridges. ಈ ಎರಡು ಬ್ರಿಡ್ಜಸ್ ನಡುವಿಂದ ನೀವು ಲೆಂತ್ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೋಬೇಕು. that is called resonating length. When that paper will fall down, when the frequency of this tuning fork and the frequency of the vibration of the wire both becomes equal, it means when the resonance occurs, at that time the paper rider will fall down and the distance between the two bridges is called resonating length. That is what we have to note down in this practical. So for the first trial we'll use this tuning fork. In next ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ frequency ಇರುವಂತ tuning fork ಅನ್ನು ತಗೊಂತೀನಿ. I will take a tuning fork of greater frequency than this. At that time what you have to do, for this tuning fork you have kept it 30 centimeter distance. So next ನಾ ಈಗ 256 ಗಿಂತ ಜಾಸ್ತಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂತ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಏನಾದ್ರು ತಗೊಂಡ್ರೆ you decrease the length by 2 or 3 centimeter. 30 ಇತ್ತೆ ನೀವು 27 or 26 ಈ ಡಿಸ್ಟೆನ್ಸ್ ಗೆ ತಗೊಂಡ್ ಬಂದು ಇಡ್ರಿ. And again repeat the same procedure. Hit it, keep it on the vibration, place it on the sonometer and go on increasing the length by 1 centimeter. At a certain distance you will get the resonating length. So like this you have to repeat this entire procedure, the same procedure for all 5 tuning forks. We are not going to change the mass here, length navile weight change ಮಾಡಂಗಿಲ್ಲ, just tuning forks ನಾವು change ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು, resonating length ನಾವು note down ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. That is what we are going to follow, right? Okay, now we are going to see the closer look of all this and we'll go step by step, right? Okay, you can find two knife edged bridges here. These are the two knife edged bridges, and on the wire we have placed a paper rider. One paper rider ನಾವು ಇಲ್ಲಿ wire ಮೇಲೆ ಇಟ್ಕೊಂಡಿದ್ದೀವಿ, ಇದು ನಿಮಗೆ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗಬೇಕು, right? So we have placed a paper rider on the wire there. Okay, next, how to take the distance between these two knife edged bridges? ಯಾವ ತರ ಡಿಸ್ಟೆನ್ಸ್ ಗಳನ್ನು ತಗೋಬೇಕು, ಈಗ ನೀವು ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ. See, the first knife edge I have kept it as 65 cm, 65th division ಕನ್ನ ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ನೀವು ನೋಡಬಹುದು, there is a straight line on the knife edged bridge. ಇಲ್ಲಿ ಒಂದು vertical line ನಿಮಗೆ ಕಾಣಿಸುತ್ತೆ. That vertical line should be exactly on 65th division. Now the knife edged bridge is at 65 ಅಂತ ಅರ್ಥ, ಕರೆಕ್ಟ್? ಸೊ ಫಸ್ಟ್ ನಾನು 30 ಸೆಂಟಿಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಇಟ್ಕೋಬೇಕು ಅಂತ ಹೇಳಿದ್ದೀನಿ. ನಾನು ಈಗ 256 ಹರ್ಟ್ಸ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ 35 ಸೆಂಟಿಮೀಟರ್, ಸಾರಿ 30 ಸೆಂಟಿಮೀಟರ್. ಸೊ 65, then this has to be at 35. So this is at 35. So how much is the distance between the two knife edge bridges now? It is 30 centimeter. See, ನಾವಿಲ್ಲಿ weight ಏನು ಹಾಕೊಂಡಿದ್ದೀವಲ್ಲ, we are not going to change the weight. Weight is going to remain same. How much is the weight here? The weight we have taken here is 2.5 kg. Right? Each is of 500 grams. 500 grams, 1 kg, 1.5 kg, 2.5 kg. So this we are going to keep fixed. We are not going to change this. Only thing we are going to change is we are going to change the frequency of the tuning fork. I mean the tuning fork we are going to change. Clear? Okay, now we'll see how to set the tuning fork in vibration and how the paper rider will vibrate. That we will see. Okay, see what we have to do now is, you take the tuning fork, this is of 256 hertz, you should set it in the vibration and you should hold it here. The distance between the two bridges is 30 centimeter. See, I will set it in vibration and I will press it here on the sonometer, and you check the vibration of the paper. Right? It is vibrating a little bit. Check once more. Right? It is vibrating. So lightly it is vibrating. So what we have to do? We have to increase the distance between the two bridges. So ಈಗ ಇದು 65 ಇದೆ, ಇದು 35 ಇದೆ, ಅಂದ್ರೆ 30 centimeter distance adri. The distance is 30 centimeter. I will increase it by 1 centimeter now. So instead of keeping at 35, I will keep it at 34. So I will increase the distance by 1 centimeter. Now you check it. Yes, it is vibrating. So we'll check it once more. Sorry. Yeah, it is vibrating more. So again, try to increase the length by 0.5 centimeter now. So by 0.5 centimeter, I will increase the length. Not ಈಗ vibration ಕಡಿಮೆ ಆಯ್ತು, ನಾ 0.5 centimeter ಹೆಚ್ಚು ಮಾಡಿದ ಕೂಡಲೇ vibration ಕಮ್ಮಿ ಆಯ್ತು. So you decrease the length now again. So decrease ಮಾಡ್ರಿ, you keep it at 34 again. Sometimes it will vibrate. Yes, it is vibrating with maximum amplitude. I will decrease by 0.5 centimeter again. Yes, so this is how it will fall, right? So ನೀವು ಅಲ್ಲೇ ಈಗ ನಿಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೈಬ್ರೇಷನ್ ಎಲ್ಲಿ ಕಾಣಿಸ್ತದಲ್ಲ, ಅಲ್ಲಿಂದ 0.5 ಸೆಂಟಿಮೀಟರ್ ಮುಂದ್ಗಡೆ ಅಥವಾ ಹಿಂದ್ಗಡೆ ನೀವು ಚೆಕ್ ಮಾಡಿ ನೋಡ್ಬೇಕು, you will get the resonating length. This is how it will vibrate and fall. So now we have to check the length, resonating length now. So we'll see how much is the resonating length now. See, resonating length ನಿಮಗೆ ಇಲ್ಲಿ ಗೊತ್ತಾಗ್ತದ್ರಿ. You can check it here. See how much is the first bridge is at 65, right? It is at 65. Clear ಇದೆ? 65. Where is the second one? Second one illade nodri. It is at 35.5. 35.5. Clear? So how much will be the distance? 60 minus 35.5 you have to take. Right? 60 minus 35.5. It will be equal to 30.5. So the first resonating length is 30.5. This is how we have to take the resonating length. So we'll have a little bit closer look to that. The resonating length I have kept the same. ನಮಗೆ ಈಗೇನು 30.5 resonating length ಬಂದ ಅಷ್ಟೇ ಅದೇ. So just I will show you closely how the paper falls and how the resonating length we will get. Sorry. Yes, this is how the paper falls, right? Okay, I guess you have seen it clearly. We'll go to the next step now. Okay, now let us continue with the chart. See, these things we had written earlier, frequencies. So weight now fixed constant ಇಟ್ಕೊಂಡಿದ್ದೀವಿ 2.5 kg. Resonating length ನೋಡ್ರಿ, ನಾವು ಈಗಾಗಲೇ ವಿಡಿಯೋದಲ್ಲಿ ನೋಡಿದ್ದೀವಿ for the first tuning fork of 256 hertz. ರೆಸೊನೇಟಿಂಗ್ ಲೆಂತ್ ನಮ್ಗೆ ಎಷ್ಟು ಬಂದಿತ್ತು 30.5 ಸೆಂಟಿಮೀಟರ್. ಅದನ್ನ ನಾವಿಲ್ಲಿ ಮೀಟರ್ ಒಳಗೆ ಬರತ್ತೀವಿ. ಸೊ ಇನ್ ಮೀಟರ್ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ 30.5 into 10 to the power minus 2, ರೈಟ್. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವೇಷನ್ ಟೇಬಲ್ ಒಳಗೂ ಕೂಡ ನೀವು ಯಾವ ಫ್ರೀಕ್ವೆನ್ಸಿ ಯಾವ್ದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ತಗೊಂಡಿರ್ತಾರಲ್ಲ ಅದರದ ಯೂನಿಟ್ ನೀವು ಕಂಪಲ್ಸರಿ ಬರೀಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಯೂನಿಟ್ ಆಫ್ ದಟ್ ಅಟ್ ಎನಿ ಕಾಸ್ಟ್, ರೈಟ್. ಓಕೆ, ಸಿ ದ ಫಸ್ಟ್ ರೆಸೊನೇಟಿಂಗ್ ಲೆಂತ್ ವಿ ಹ್ಯಾಡ್ ಗಾಟ್ ಇಟ್ as 30.5 ಸೆಂಟಿಮೀಟರ್. ಅದನ್ನ ಮೀಟರ್ ಒಳಗೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. Next column is F into L. So 256 into 30.5, it will be 7808 into 10 to the power minus 2 as it is. 1 divided by L, 1 divided by 30.5, you will get it as 0.0327. So 10 to the power minus 2, numerator bantapa antandre 10 to the power plus 2 age namagu 3.27 bartadri. Right, like this I have completed all the trials. For 288 we have got this much, 341, 426, 512. So 30.5 centimeter, 27 centimeter, 22.5 centimeter, 18 centimeter, 15.5 centimeter, right. So your frequencies resonance tuning folks ನೀವು ಏನಾದರೂ ತಗೊಂಡ್ರೆ these resonating lengths only will get 0.5 centimeter to 1 centimeter ಆ ಕಡೆ ಈ ಕಡೆ ನಿಮಗೆ ಬರಬಹುದು, right. Okay, so these are the readings. So what is the next step? We have taken all the observations. Next step is we have to draw the graph now. See, ಇಲ್ಲೇ ನೀವು ಒಂದು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. One thing you can observe, we are increasing the frequency ನೋಡ್ರಿ from 256 to 512. What we have done, we have increased the frequency. What happened to the resonating length? Resonating length ಏನಾಗಿತ್ತು ನೋಡ್ರಿ 30.5 ಇಂದ 15.5 ಅಂದ್ರೆ ಲೆಂತ್ ನಮಗೆ ಏನಾಗಿದೆ, resonating length has got decreased, right. So frequency and resonating length both have varied in opposite directions. Frequency increase ಆದ್ರೆ length decrease ಆಗೈತೆ. What does this indicates? It indicates frequency is inversely proportional to length. Frequency is inversely proportional to length, or you can say frequency is directly proportional to reciprocal of length ಅಂತ ನೀವು ಕರಿಬಹುದು. Frequency is directly proportional to reciprocal of length. That's why when you plot a graph of frequency versus 1 by L, you have to get a straight line like this. ನಿಮಗೆ ಈ ತರದ straight line ಬರಬೇಕು, right. Okay, so we'll go to the graph now. We'll see how to plot the graph. See, this is the graph. ಈ ತರ ನಾವು ಇಲ್ಲಿ ಎರಡು axes ಗಳನ್ನು ತಗೊಂಡಿದ್ದೀವಿ. This is x axis and this one is y axis. Clear? Okay, so let us go on plotting the graph now. See, this is the origin. ಇದು ನಮಗೆ origin ಅದ, correct. Okay, so how to plot the values now? ಈ ವ್ಯಾಲ್ಯೂಗಳನ್ನು ಯಾವ ತರ ಪ್ಲಾಟ್ ಮಾಡಬೇಕು? See, what all frequencies we have got. ನಮಗೆ frequencies ನೋಡ್ರಿ, ಇಲ್ಲಿ ಫಸ್ಟ್ ನಾವು ಇಲ್ಲಿ x axis ಮೇಲೆ ನಾವು ಏನು ತಗೋಬೇಕು, frequency. y axis ಮೇಲೆ ಏನು ತಗೋಬೇಕು, 1 by L, correct. So on x axis we are going to take frequency which will be in hertz ಒಳಗೆ ಇರ್ತೈತ್ರಿ frequency. On y axis we are going to take reciprocal of length which will be in per meter, reciprocal of length on y axis, correct. So check the values of frequency now. Frequency values ನೋಡ್ರಿ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಅದಾವ, 256 ಇಂದ 512 ವರೆಗೂ ನಮಗೆ frequency values ಅದಾವೆ. So what we'll do is we'll start taking the values from 225. So 225 we'll do it like this. 5 trials ಅದಾವ. So 5 trials are there. So 225. So looking at these values you have to decide. 256 ಇಂದ 512 ವರೆಗೂ ಎಲ್ಲ ಅಲ್ಲಿ ಬರಬೇಕು ನಮಗೆ, right. We have to get that. So if I start from 225, see ಇಲ್ಲಿ ನೀವು ನೋಡ್ಕೋಬೇಕು. See, ಈಗ ನಾ 2 ಸೆಂಟಿಮೀಟರ್ ಒಂದೊಂದು ಏನಾದರೂ ತಗೊಂಡ್ರೆ ಒಂದು ಬಾಕ್ಸ್ ಅಂದ್ರೆ 1 ಸೆಂಟಿಮೀಟರ್. One box means it is 1 centimeter. So if you want, you can take the values for each 2 centimeter or for each 1 centimeter. Any one way you can take. To get a broader graph, take it for 2 centimeter. So first value ಇಲ್ಲಿ ತಗೊಂತೀನಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ for this. So let me say it is 225, 250, 275, 300, 325, 350. Okay, so 512 ತನಕ ನಮಗೆ ಇಲ್ಲಿ ಬರೋದಿಲ್ಲ. So what we'll do, we'll take it 250 only. So ಇದು 250, this is 300, 350, 400, 450, 500, 550. Like this we will take, right. So you have to decide depending on the values of your observation, right. So all the values from minimum to maximum should appear here. So now ಇದು first ಏನದು, ಇದನ್ನ 250 ಅಂತ ತಗೋತೀನಿ. This is 250 and then we'll go on increasing by 50 hertz for each trial. So 250, 300, 350, 400, 450, 500, 550, right. You should take it like this. See, ನೀವು ಡೈರೆಕ್ಟ್ಲಿ ಇದನ್ನ ಇಲ್ಲಿ ಪ್ಲಾಟ್ ಮಾಡ್ಕೊ ಬರ್ತರೆ. ಈಗ ಏನು ನಮಗೆ 256, 288, 341 ಅದಲ್ಲ, ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಇಲ್ಲಿ ಹಾಕೋಬಾರ್ದು. ವೈ? ಯಾಕಂದ್ರೆ ದೇ ಆರ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ದ ಈಕ್ವಲ್ ಡಿಫ್ರೆನ್ಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ದಮ್. ಈಕ್ವಲ್ ಡಿಫ್ರೆನ್ಸ್ ಇಲ್ಲ, ನಿಮಗೆ ಸ್ಕೇಲ್ ಬರ್ಲಿಕ್ಕೆ ಬರಂಗಿಲ್ರಿ. ಇದನ್ನ ಏನಾದ್ರೂ ನೀವು ಇಲ್ಲಿ ಬರ್ಕೊಂಡ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ you cannot write the scale if you note it down directly here. So you should write it like this. Equal difference ಇರೋಂಗ ನೀವು ಅದನ್ನ ಬರ್ಕೊಬೇಕು. Okay, now let us write the scale of this x axis. See, we'll write the scale. Okay, for x axis, what is the scale that we will write? See, for x axis, what we have done, we have plotted every value for per 2 centimeter. ಪ್ರತಿ 2 ಸೆಂಟಿಮೀಟರ್ ನಾವು ಒಂದು ವ್ಯಾಲ್ಯೂ ತಗೊಂಡಿದ್ದೀವಿ. So here I will write for x-axis 2 centimeter equal to 2 centimeter equal to ಯಾಕರಿ ಇಲ್ಲಿ ನೋಡ್ರಿ origin ದಿಂದ 250 ನಮಗೆ 2 centimeter ಅದ ಇಲ್ಲಿ ನಮಗೆ 2 centimeter ಅದ ಇದು 2 centimeter ಅದ. So for every 2 centimeter I have plotted one value. That's why I am writing it as 2 centimeter equal to. Okay, next, what is the difference? 300 minus 250, 50 hertz. 350 minus 300, 50 hertz. 400 minus 350, 50 hertz. So equal difference we are having. So here I will write it as 50 hertz, right? 50 hertz. Clear? Okay. Similarly, now plot the values on y-axis. So y-axis ಮೇಲೆ ನಮಗೆ resonating length the reciprocal ನಾವು ಹಾಕಬೇಕು. So check the values of resonating length reciprocal. Reciprocal of resonating length the values ನೋಡ್ರಿ. It starts from 3.27 and it is ending at 6.45. Correct? So we'll begin it from here. So 2 cm ಕೊಂದು ನಾನು ತಗೋತೀನಿ. So this is 3.25 ಅಂತ ನಾನು ತಗೋತೀನಿ. 3.25, 3.50, 3.75, 4, 4.25, 4.50, 4.75, 5, 5.25. Okay, ನಮಗೆ ಇಲ್ಲಿ 6.45 ಬರಲಿಕ್ಕೆ it is not enough. So what we'll do, we'll take it like this, 3.25, then directly we'll take 3.75. 3.75. It means 0.50 we will increase, 0.50. So 3.25, 3.75 plus 50 ಅಂತಂದ್ರೆ ಇದು ನಮಗೆ 4.25 ಬರ್ತದೆ. Plus 0.5 means, okay, plus 4.75. 4.75. Okay, next, 5.25. 5.25. Next, this will be 6.25, right? And this will be 6.75, right? Sorry, we have skipped one thing here. So here it should be 5.75. 5.25, 5.75, and this has to be 6.25. 6.25, and this will be 6.75. Clear? So like this we have to take the values. Okay, now go on plotting the values now. See, check the values in your observation table and then plot the graph. First trial, how much it is? First trial notary 256, frequency is 256, this is 250, this is 300, so this will be 275. Either 275 irtade namu 256 andre somewhere here it will be, correct? So ille namu 256 irtadri. How much is 1 by L? 3.27. So 256, 3.27. So this is 3.25, 3.27 andre somewhere here it will be. So this is the first point. Clear? Okay, next notary 256 aita 288. How much is the value of 1 by L? 370. So 288, 370. 288 means somewhere here it will be 288 and 370. So this is 375. 288, 375, 370, 70 antadre here it will be. Somewhere here it will be. Correct? Okay. Next, what is the next value? Next value is 341, 4.44. 341. So this is 300, this is 350, this is 325, 341 here it will be close to 350. 341, 4.44. So this is 4.25. So 4.44 will be somewhere here. 4.44, 4.44 somewhere here it will be. Clear? Okay. So that's all about the third trial. Fourth trial 426. See, idu 425 irtadre. This is 425. 426 means here it will be 426, 5.55. So 426, 5. This is 5.25. This will be 5.50, right? So 455. So somewhere here it will be. Clear? So here will be the value. Next, next trial is 420. Sorry, 426 is over now. Last trial 512, 6.45. 512. So 512 will be somewhere here. Somewhere here. 512. 512. How much is the 1 by L? 6.45. So 6.25 this is. 6.45 somewhere it will be here. 6.45. 6.45. Correct? So here we will get it. Because this is 6.50. Clear? So we have got the values like this now. What we have to do is we have to draw a straight line from origin which joins all these points. Right? ಈ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನು ಜಾಯಿನ್ ಮಾಡುವಂತ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ನೀವು ಡ್ರಾ ಮಾಡಬೇಕು. Clear? So some points, at least 2 to 3 points we have to get on the straight line. So this is how we have to draw it. Correct? Like this we will get it. ಒಂದು 2 ಪಾಯಿಂಟ್ ಆ ಕಡೆ ಉಳಿದ್ರೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ. We can draw the straight line like this. Clear? Okay. So this is how we have to draw the graph. So in graph it is clear that since we have got a straight line from the origin, it is clear that frequency is directly proportional to 1 by L, right? Since these both are directly proportional, that's why we have got a straight line here, right? Hence this proves the result. Okay, now we'll go for the result. So the result is like this. The result is like this. See, the result is the product of F into L is found to be constant. Product of F into L. So ನಿಮಗೆ product of F into L ಎಷ್ಟು ಬಂದಿದೆ ಇಲ್ಲಿ ನೋಡಿ. Product of F into L. So product of F into L is almost constant. ಅಂದ್ರೆ 7800, 7700, 706. So almost constant ನಿಮಗೆ ಬಂದದ್ರಿ. ಅಂದ್ರೆ 78, 76, 77 in this, right? Okay. Next, the graph between F and 1 by L is a straight line passing through the origin. Yes, that we have got. Third is, this concludes that the frequency of vibrating wire is inversely proportional to the resonating length under constant tension. That we have already seen. Frequency is inversely proportional to the resonating length, right? So that's all about this practical. This is the first aim or the first part of the sonometer practical. Next, second part of the sonometer we'll see in the next video. Dear students, if you like the content of this channel, please don't forget to subscribe, and please don't forget to share the video and share the channel with your friends. Please, I am requesting you all subscribe and share the channel as well as share the video with your friends. Thank you so much. If you need anything else, please put a comment. We'll surely make a video on that. Thank you so much. Keep watching and keep supporting.